It's a strange thing, but a system's success often seems to contain the blueprint for its eventual failure. A small, efficient team grows into a large, slow bureaucracy. A simple, useful technology becomes a complex, fragile platform. This isn't an accident. It's a fundamental dynamic of how systems operate. And in this explainer, we're going to break that dynamic down. So let's start with a really common and intuitive assumption. The idea is that when you add more components to a system, more people, more servers, more features, you increase its overall value. Each new piece just seems like a clear, positive addition. But what we actually observe is a paradox. As a system scales up, getting bigger and seemingly more valuable, it's also, at the exact same time, approaching a state of maximum fragility. It becomes brittle, unpredictable, and vulnerable to pressures that it used to handle with ease. Okay, so to really get our heads around this paradox, we first need to look at the engine that's driving the system's growth. You see, the value doesn't just come from the components themselves. It comes from the connections between them. This whole idea is often described by something called Metcalfe's law. What it states is that the potential value of a system doesn't just grow linearly with each new component. No, it grows exponentially. And this creates a really powerful positive feedback loop. More components create way more value, which in turn attracts even more components. Let's visualize this. Imagine a system with just two components, or nodes. Well, there's only one possible connection between them. The value is pretty limited. But what happens if we grow that system to just 5 components? Suddenly, the number of potential connections jumps all the way to 10. So a small increase in parts creates a much, much larger increase in potential interactions. And this is where you really start to see the accelerating nature of this law. By the time the system gets to 12 components, it now has 66 potential connections. The whole network of relationships has become vastly more dense. The crucial point is this. You're adding new components one by one. That's a linear process. But the potential value of the system, which comes from that web of connections, is scaling up exponentially. This is the engine of growth. It's the force that pushes every successful system to expand. But here's the catch. That explosion in valuable connections, it's not the only thing that's scaling. There's an unseen cost, a kind of hidden drag that grows right along with it. We can call this cost coordination overhead. It's all the energy, resources, and time that it takes to manage the relationships between all the components in the system. So while every new connection adds potential value, it also introduces a very real cost. You have to think of a connection not just as a pathway for value, but also as a liability. Each one of those links has to be maintained, managed, and secured. And as that web of connections gets bigger, so does the burden of just keeping the system coherent. And on top of that, every single connection becomes another potential point of failure. It's a channel for miscommunication, a place where dependencies can break, or even a route for a tiny local problem to cascade into a massive system-wide crisis. Now, in the early stages of a system's life, the value you get from new connections far outweighs the cost of this growing complexity. But this invisible drag is always accumulating, and eventually it leads the system to a critical tipping point. Sooner or later, the system hits this point where the escalating cost of complexity, all the maintenance, the coordination, the risk, starts to surpass the value being generated by new connections. And from this moment on, the entire math of growth just flips on its head. Once that threshold is crossed, the system's main activity shifts. It starts spending more of its resources just managing its own internal complexity, instead of producing external value. Adding a new component now actually costs more in overhead than it contributes in value. Growth, the very engine of success, becomes a liability. The failure that often comes next isn't caused by a single mistake that you can point to. Instead, it emerges from the system's own structure. The system becomes so complex that it actually goes beyond the limits of predictability. To really wrap our heads around this limit, we can draw a helpful analogy from a field called computability theory. This field suggests that there are fundamental boundaries on what can be predicted, even by the most powerful computers imaginable. Take the halting problem, for instance. It's been proven that it is impossible to create one single algorithm that can look at any other computer program and predict with 100% certainty whether it's going to finish its task or just get stuck running forever. It shows a fundamental limit to prediction in complex systems. So, by analogy, a system made of people and processes can become so internally complex, with so many feedback loops and interdependencies, that its own failure modes become fundamentally unpredictable from the inside. There's just no simple way to analyze it and guarantee it won't break. What all of this reveals is a core dynamic, a fundamental trade-off that is just inherent to all interconnected systems, whether we're talking about organizations, technologies, or even ecosystems. The process follows this predictable, repeating loop. First, connection creates value. That value then drives scaling. But scaling creates complexity. And finally, that very complexity becomes the hard limit that stops further scaling. The engine of growth creates its own break. And this, right here, is the central insight. The mechanism for success is inextricably linked to the mechanism for failure. The positive feedback loop of connection-driven value is perfectly mirrored by a negative feedback loop of complexity-driven fragility. You simply cannot have one without the other. So ultimately, this exposes a fundamental trade-off. And it's not a simple choice between success and failure. It's a constant dynamic tension between two competing virtues: the drive for growth and the necessity of coherence. In any scaling system, there comes a point where one can only be purchased at the expense of the other.